Recording has started.
So for number one, since x is all by itself, we can use that shortcut of just cross multiply and divide. So we take the two numbers that are diagonal with each other, the 35 and the 21, and we'll multiply those. 35 times 21 is going to give us 735. Now we divide that by the number that's diagonal to our x. So we divide by 15 to give us 49. So here x equals 49. For the second one here, because x is not by itself, we can't use the shortcut. We're going to have to use the full cross multiplication. So going this way, we have 20 times 3x plus 3. And that has to equal, going this way, we have 12 times 45, which is 540. So now to solve this, we'll distribute the 20. 20 times 3x is 60x. 20 times 3 is 60, equals 540. And now we'll solve. We'll subtract 60. 60x equals 480. Divide by 60. X equals 8. Number 3, we also have to do the full cross multiplication here. Going in this direction, we have 15 times 5x plus 5. That'll have to equal, going in this direction, we have 50 times 2x minus 1. So now we'll do the distributing. 15 times 5x is 75x. 15 times 5 is 75. Equals 50 times 2x is 100x. And 50 times negative 1 is a negative 50. So now we've combined what we need to on each side of that equation. We have to make sure the variable is on only one side. Right now it's on both sides. So we'll find the smaller one, which is the 75. It's positive, so we're going to get rid of it by subtracting it. And we have to remember we have to subtract it from the other side as well. So we're left with just 75 on the left. 100x minus 75x is 25x minus 50. Now we can solve this, so we'll go ahead and add 50. 125 equals 25x. And we can divide by 25. Get 5 equals x. So those are solving the proportions from yesterday. Like I said, most of the time those proportions are in a word problem setting, some sort of a setting, and we have to pick out the right information. Today we're moving on to a related topic called variation. And variation is just how two numbers, two quantities, interact with each other. And there are really only two ways. If we only have two numbers, there's only two ways they can interact. The first one is called direct variation. In direct variation, we're just going to call our two numbers for right now x and y. If x gets larger, y also has to get larger in a proportional amount. Or, if x gets smaller, y also has to get smaller. Their changes are directly related. Whatever one does, the other one has to do in a proportional manner. Direct variation is often referred to as a constant ratio. So what that means is the ratio between x and y over x equals a constant. Now it's typical to rewrite this in an alternative form. Just because it's a little easier to have it as an equation instead of y divided by x equals a constant, it's just y equals a constant times x. That's the most commonly used form for direct variation. Oops. Yeah. So, if we are told that P varies directly with M, what that is telling us is that P equals a constant times M. There's a direct relationship. We might be told more than that. We might be told that F varies directly as Q, and when Q is 8, F is 32. So now we have two pieces of information that we can process here. F varies directly with Q is telling us that F is equal to a constant times Q. But then we also have that when Q is 8, F is 32, which means we can find out what K is. We put 32 in for F. We leave the K there. We put 8 in for Q. Q is now the only variable left in this relationship. It's the only unknown. So we can solve for Q, for K, I should say, by dividing by 8. 4 equals K. Well, now that we know that K equals 4, we can further define this relationship using that K equals 4. Instead of F equals K times Q, we can say F equals 4 times Q. And we could go another step yet. We might have D varies directly with N when N is 6, D is 42. Find D when N is 10. Now we have two pieces of information and then a command or a question here. D varies directly with N is telling us that D equals the constant times N. When N is 6, D equals 42. I put 42 in for D and 6 in for N. And I solve. I can divide by 6 here to get that 7 equals K, or K equals 7. So that tells us that this relationship is not just D equals Kn, it's D equals 7 times N. Now we're asked to find D when N is 10. So we put 10 in for N, so D equals 7N becomes D equals 7 times 10. And we just multiply. 7 times 10 is 70. So D would be 70 when N is 10. It's not always quite that straightforward. We might have varies directly as the square root of M. When M is 9, P is 42. Find P when M is 25. So again, here we're given two pieces of information and then a command or a question. First, we're starting off with P varies directly, not as directly with M, but directly with the square root of M. So that means P equals K times the square root of M. Now the second piece of information still is a known condition of some sort. When M is 9, P is 42. So we put 42 in for P and 9 in for M. There's a little bit more work to do this time. We have to do the square root of 9, which is 3. So 42 equals K times 3. And then we can divide to find K. We divide by 3 to get 14 equals K. So that tells us that this relationship here is really P equals 14 times the square root of M. And now we're asked to find P when M is 25. So we just put 25 into the formula for M. So P equals 14 times the square root of 25. Well, the square root of 25 is 5. So P equals 14 times 5, or P equals 70. When M equals 25. So why do we care about these relationships? Well, they do come up quite a bit in math. And in engineering especially, there's a lot of times you know that two values are directly related, but you don't necessarily know their equation. So you can take an initial condition or a known condition like this, take a measurement. Okay, M is currently 9 and P is currently 42, so that helps me figure out the relationship. For example, when resistance is constant, voltage varies directly with current. When the current is 3 amps, the voltage is 120 volts. Find the voltage when the current is 4 amps. So here we have voltage varies directly with current. So V equals a constant times, I'm going to use I for current because that's the symbol that's typically used. Now we can find K, that constant, because when the current is 3 amps, the voltage is 120 volts. Put 120 in for V, 3 in for I, and now we'll solve for K by dividing by 3. We get 40 equals K, or K equals 40. So that means this relationship up here, I can replace the K with 40. The voltage is actually equal to 40 times the current, 40I. Find the voltage when the current is 4. So we put 4 amps in for I. And we just multiply. 40 times 4 is going to be 160 amps. Sorry, volts. So the voltage is 160 volts when the current is 4 amps. Now, most of you will recognize this formula right here from direct current. V equals resistance times current, or current times resistance, no matter which way you want to put them. It's the same formula. So here, the constant, the K, is representing that resistance. Remember, we started out when the resistance is held constant. So actually, the resistance is the constant in that relationship. The other type of variance that we have is inverse relationship. Inverse variance. So we'll call it inversely related. In values that are inversely related, or inverse variation, if x gets larger, y has to get smaller by a related amount. Or the other is true. Oh, sorry. If x gets smaller, y has to get larger, again, by a related amount. Inverse variation is often referred to as a constant product. What that means is it is x times y equals a constant. Now, there's an alternative form again. Rather than x times y equals a constant, we want it to be y equals something. So if we divide both sides by x, we get y equals a constant divided by x. So direct variation was y equals a constant times x. In inverse variation, y equals a constant divided by x. So if we were told m varies inversely as d, that is telling us m equals a constant divided by d. Now again, we can have more information, just like direct variation. We might be told that P varies inversely with K. Oops, I don't want to use K because that's my constant. Let's do P varies inversely with T. When T is 8, P is 6. So this is a known condition here that we're given. We can expand on our formula. So P varies inversely with T, again, is telling us that P equals constant divided by T. And then we have this known condition, this piece of information. When T is 8, P is 6. We put 6 in for P. And we can solve for K. We're going to multiply both sides by 8. 6 times 8 is 48 equals. On the other side, the 8 cancels out. We have K. So the constant is 48. So we can combine that with our initial relationship to get, rather than P equals K divided by T, P equals 48 divided by T. We can just go that third step again, just like we did with direct variation. We might have F varies inversely with B. When B is 2, F is 12. Find F when B is 6. So our relationship here exists. F varies inversely with B. That's saying F equals a constant divided by B. We have our second piece of information, or our known condition. When B is 2, F is 12. So F is 12, B is 2. And we can solve for K. So I'm going to multiply by 2. 12 times 2 is 24 equals, on this side the 2's just cancel out, I have K equals 24. So this relationship here now can be clarified as F equals 24 divided by B. And then we're asked, find F when B is 6. I just put 6 in for B. And I divide. 24 divided by 6, F is 4 when B is 6. Now again, this might not be as steady as this, or simple as this all the time. We might have B varies inversely with the square of B. When B equals 5, B is 125. Find V. Oh, let me get that. Let's do this. When B equals 5, let's say that V equals 4. We'll make it a little simpler on it. Find V when B is 10. So again, we start off with a relationship. B varies direct or inversely with the square of B. So that's saying V equals K over B. We have this known condition. B equals 5, V equals 4. So put 4 in for V. The square of B, of course, that would be B squared there, not just B. So, B is 4 when B is 5, so that'll be 5 squared down there. And we do have to work that out. 5 squared is going to be 25. So 4 equals K over 25. Now we can solve for K. We're going to multiply by 25. 4 times 25 is 100. On the right side, the 25's cancel out. We have K. K equals 100. So we can clarify this relationship with that value of the constant. V does not just equal K over B squared. V equals 100 over B squared. So now, find V when B is 10. We put 10 in for B, so it's V equals 100 over 10 squared. 10 squared is 100. So V equals 100 divided by 100, or V equals 1 when B equals 10. Back to our electronics. Let's say if the voltage is constant. Current is inversely related to resistance. When the resistance is 60 ohms. Current is 2 amps. Find the current when the resistance is 40 ohms. So once again, we have a relationship here. Current is inversely related to resistance. So I'm going to use I for current again, equals constant divided by our resistance. But we do have a known condition. When the resistance is 60, the current is 2. So I put 2 in for I for the current, equals K divided by, I put 60 in for the resistance. I'll multiply by 60. 2 times 60 is 120. On the right side, the 60s just cancel out, giving us K. So 120 equals K. So I can clarify this relationship here again by putting that constant in. I does not just equal K divided by R, it's actually 120 divided by R. And now we're asked to find the current when the resistance is 40 ohms. So we put 40 in for R. 120 divided by 40 is 3 amps. Current is 3 amps when the resistance is 40 ohms. Now, there are a lot of applications of either of these in mechanics and all sorts of other things. For example, let's talk about mechanical advantage. A simple machine, a lever, a pulley, whatever, is designed to have a mechanical advantage. The mechanical advantage is usually you can output more force than what you put in. Whatever force you put in is multiplied to get a greater force coming out. However, mechanical advantage can be the opposite way. You can actually output less force than you put in to gain speed. That the speed of movement, the output speed, is way faster than what you're putting in. But let's say that for a pulley system, the output force is directly related to the input force. When the input force is 60 pounds, the output force is 200 pounds. Find the output force when the input force is 100 pounds. So here we have output force is directly related to input force. So I'm just going to call them O and I. So the output force is a constant times the input force. When the input force is 60, the output force is 200. So we put 200 in for the output, equals K times 60 is our input. Now we'll solve for K here. We're going to divide by 60. That gives us 200 divided by 60. Well, that doesn't divide out evenly, so I'm going to make it a fraction and reduce it. So both divide by 20. Let's see what that does. 200 divided by 20 is 10. 6 divided by 20 is 3. So that's 10 thirds, or 3 1/3. I'm just going to leave it as 10 thirds equals K. So that is telling us that this relationship is our output force equals 10 thirds times the input force. So we're asked, find the output when the input's 100 pounds. So 10 thirds times 100. The output force is 333 1/3 pounds. When the input force is 100 pounds. A lever, however you want to put it, converts distance into force. So the amount of force that a lever can exert is inversely related to the distance from the fulcrum, or from the pivot. So let's say the force required to lift a weight is inversely related to the distance from a pivot. When the distance is 30 inches, the force required is 80 pounds. Find the force when the distance is 60 inches. So here we have this relationship. The force required is inversely related to the distance from the pivot. So the force equals a constant divided by a distance. F equals K over D. We have that known condition. When the distance is 30 inches, the force is 80 pounds. So 80 equals K over 30. So we're going to solve for K here by multiplying by 30. So 2400 equals K. So we can put that back into this relationship to get to the force equals 2400 divided by the distance. Asked what is the force when the distance is 60. So we put 60 in for D. And that gives us the force is now 40 pounds. When the distance is 60 inches. Now, if you look at this, this makes sense. If these are inversely related, we doubled the distance from 30 to 60 inches. The force required is inversely related. The distance doubled, the force is cut in half from 80 to 40 pounds. That's how inverse relationship works. If I tripled one of them, the other one would be cut to a third. To practice each of these, you have homework on page 294, exercise 7.3. problems 1 through 53, the odd. And also page 297. Exercise 7.4, 1 through 43, the odd. Now, as I mentioned yesterday, we only have 4 more classes after today. Class time next Thursday on the 17th is it. At that point, it's done. So there are many of you that have missing quizzes, or even a couple of you have missing unit tests. You need to have that in to me by the end of class next Thursday. So make sure you look through the Blackboard grade book. Everything should be updated in there. There's a couple of things I have left to grade, but you can see that you've submitted it. If you have any zeros, make sure you're working on that. Make sure you complete those and turn them in. Also, there's a new quiz out there today on ratio and proportion. That's a relatively easy one. Make sure you get that one done. It should be easier points for you than some of the past quizzes. To be totally honest, right now, if the course ended today, there are a few of you that would not pass the course. Don't want to have you rearrange your schedule to retake the class next semester. So make sure you look through. If you're missing anything, get it done and turn it in so that we can get those points for you so we can get you through. Anybody have any questions? Okay, well, that is all we have for today. So I'll let you have the last 10 minutes to get started on the homework.